Okay, so let's see if we can solve some simple equations here. Suppose I have the equation 3x plus 7x plus 5 is equal to 9. Okay, how do you go about solving this equation? The first step is combining all the terms that have x in them. First you combine all these terms, then you combine all the terms that don't have x in them. You put all of those terms that do not have x in them on the right hand side of the equation. So this 5 would go here, and all the terms that do have x in them stay on the left hand side. So for this one, we combine all the terms in x, so 3x plus 7x will be equal to 10x. So 10x stays on the left hand side. You write the equal sign, and now to move the 5 from the left hand side into the right hand side, you have to invert the sign. So if it has a plus sign, you convert into a minus sign and push it into the right hand side. If it is a minus sign, you transform it into a positive sign. So in this case we get 10x is equal to, now the 9 stays where it is, and the plus 5 becomes a minus 5, and you put it onto the right hand side. So 10x is equal to, now 9 minus 5 is equal to 4, so you write the 4 there. And so here you see you have a number multiplying x. So the first step was to sum, to add up all the numbers that have x in them. After you've done that, you will get a single number multiplying x equals a single number that doesn't have x in it on the right hand side. So the next step, you need to get rid of this 10 and get x alone. So this means that you have to divide both sides by 10, because division is the inverse of multiplication. So if you have a number multiplying x and you want to get x on its own, you have to divide by that number. So let's see, why is that true? Because if we divide both sides of the equation by 10, then this 10 cancels with this 10, and you're left with just x. So then you get just x is equal to 4 over 10. And now you can simplify this if you like. You can divide top and bottom by 2, so you get 2 over 10. So this is the result. You can leave it in as a fraction form if you like. So x equals 2 over 10, and 2 over 5, sorry. So this is 2 over 5. Let me just erase this here. So it should be 10 over 5. Okay, so it should be 2 over 5, and this is the answer. So x is equal to 2 over 5. So this is the answer to the equation. If x is equal to 2/5, then this equation is true. This equation makes sense. And you can confirm that this is true if you rewrite 2/5 for x, and here, so then you get 3 times 2/5 plus 7 times 2/5 plus 5 is equal to 9. Now 3 times 2 is 6, so you get 6 over 5 plus 7 times 2 is 14. 14 over 5 plus 5 will be equal to, now 14 plus 6 is equal to 20, so you get 20 over 5 plus 5, which is equal to, now 20 over 5 is equal to 4, so 4 plus 5 is equal to 9. So this 9 is equal to this 9 here, so that means the equation is true and it makes sense. So this is what's called a linear equation, and a linear equation involves just x, it doesn't involve powers of x. So let's try another one. So suppose we have 5x plus 1 is equal to 7x. So in this case, again, we get all the terms that have x in them onto the left hand side and invert the sign. So we still get 5x here. Now the 7x becomes a minus 7x here, equals, the plus 1 becomes a minus 1 there. Okay, so 5x minus 7x is equal to minus 2x, and this is equal to minus 1. Now you see that there are minuses on both sides of the equation, so you can cancel this by making them all pluses, and that's equivalent to multiplying both sides of the equation by -1. So you get that 2x is equal to 1, and finally x is equal to 1 over 2, dividing both sides of the equation by 2. Now, many people don't understand why it is that you have to divide both sides of the equation by a certain number to get x alone, and why is it that sometimes you have to add and subtract. That's because whenever you have an equation, you have something here equals something here. Whatever you do to the left hand side of the equation, you have to do to the right hand side, so the equation balances. So the equation is true. If the equation is true for these values here and these values here, then whatever you do to the left hand side, if you still do it to the right hand side, the equation is still going to be true. For example, if 2x plus 1 is equal to 5, if this is true, then whatever you do to the left hand side, you have to do to the right hand side for the equation to still be true. So you can do anything to the left hand side and right hand side. You can multiply it by a constant, for example 5, so you multiply the right hand side by 5 as well, the equation is still true. You can, for example, you have 2x plus 1 equals 5. You can, for example, add a number. For example, let's add a variable plus a, the equation is still true. You can subtract, can do minus a plus 2x plus 1 is equal to 5 minus a, the equation is still true. You can also, another thing that you can do is you can raise both sides to a power. So for example, if you have an equation 5x plus 2 is equal to x, you can raise both sides of this equation to a certain power. For example, a, you can say that a to the 5x plus 2 is equal to a to the x, the equation is still true. You can also take the logarithm of both sides. So for example, if you have 2x plus 1 equals 5, you can take the logarithm of both sides, 2x plus 1 here, so it's equal to the log of 5, the equation is still true. Of course, there are some constraints. 2x plus 1 has to be greater than 0, because the log function is only defined for numbers greater than 0. And so whatever you have, whatever expression you have here, you have to do whatever you do to the left hand side, you do it to the right hand side. So to separate the variables, for example, if 5x is equal to 9, then you want to get x alone, so whatever you do to the left hand side, you do to the right hand side. So you do something that will free x and leave it on its own. So the thing to do here is to divide both sides by 5. So this 5 and this 5 cancels, and you get x is equal to 9 over 5. Okay, so let's move on. Suppose we have how to solve a quadratic equation, so a equation that involves x squared. So if we have equations involving x squared, let me create an equation here that involves x squared. Let's suppose I have the equation x minus 3 times x plus 1 is equal to 0. Now it's very easy to solve this equation. As you can see that this equation is going to be 0 whenever x is equal to 3 or x is equal to minus 1, because if x is equal to 3 here, then 3 minus 3 is 0, and 0 times anything is 0. If x is equal to minus 1, then minus 1 plus 1 is going to be 0. So if the equation is in this form here, it's very easy to solve. It's practically already solved for you. And so the more difficult part is if the equation is not in this form. For example, if you multiply out these two terms, then you get x squared plus x minus 3x plus minus 3 is equal to 0. You just multiply x by 1, minus 3 by x, and minus 3 by 1. Then you simplify, so you get x squared. Now x minus 3x is minus 2x, minus 3 is equal to 0. Now this is exactly the same equation as this one, so it has exactly the same solutions. But as you can see, you cannot see immediately what the values of x are for this. So if you are given an equation of this form, one thing you can do is to try to transform it from this form into this form. And to do that, you have to look. You first write down. You write down in parentheses. Then you write the x here and the x here. So x times x is gonna give you x squared. So you have the x squared. Now you have to find the number to put here and here has to be a number that when you multiply them together it gives you -3, and when you add them together and multiply by x it gives you -2. So the only numbers you have to multiply together to give you 3 is 1 and 3. So you have 1 here and 3 here. Now you need to take care of the minus signs. So in this case you have to see whether this is a plus and this is a plus, or this is a minus and this is a minus, or minus and plus. So the signs have to make sense for this equation. So in order for you to get a 3, you have to have one being a negative and the other one being positive. Now you have to decide which one is the positive and which one is the negative. Which one is this one supposed to be +3 and this -1, or is this supposed to be -3 and this +1? So you try it out. So if this is minus and this is plus, then you have here that 1 times -1 times 3 is going to give you -3, but the this x times this 3 is going to give you 3x, and this -1 times x is going to give you -x. So you get 3x minus x, which is equal to 2x. Now we don't have 2x here, we have -2x. So this means that this is incorrect and the opposite must be true. So this must mean then that this is minus and this is plus. If this is minus and this is plus, then you still get the -3 here. When you multiply 1 by -3, you get -3 here, and then when you multiply the x by the constants, this x times this -3 gives you -3x, and this 1 times the x gives you +x. So -3x plus x is equal to -2x, and -2x is what you have here. So the correct factorization is actually x plus 1 times x minus 3 equals 0, and from this you can see the solution. So this is exactly what we had before. There's also another way to solve this equation by using the quadratic formula. So let's copy this equation back here again. So if we want to solve this equation, we can also use the formula that x is equal to minus b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. Now what is b, what is a, and what is c? The coefficient multiplying x squared is a, the coefficient multiplying x is b, and the constant is c. So you have to say here that a is equal to +1, b is equal to -2, and c is equal to -3. So you just substitute these numbers into this equation and you get the correct answer. So x is equal to -b. Now minus b is -2, which is equal to +2. Then you get plus or minus times the square root of, now b squared is 4, then 4 minus 4 times a is 1, and c is -3. All of this divided by 2a, which is 2. So x is equal to 2 plus or minus the square roots of, now you simplify this guy, so here you get 4 minus 4 times -3. Now this 3 and this minus and this minus becomes a plus, so you get 4 plus 4 times 3 is 12, so 4 plus 12. Now 4 plus 12 is 16, so you write the 16 there, divided by 2. So this means that x is equal to 2 plus or minus the square root of 16 is 4, and you divide the result by 2. So this is equal to, now You can divide top and bottom of this fraction by 2, so you get 1 plus or minus 2. So x is equal to 1 plus or minus 2. So that means that x is equal to 1 plus 2, or x is equal to 1 minus 2. Now 1 plus 2 is 3, and 1 minus 2 is minus 1. So x is equal to 3 or minus 1, which is exactly what we had before. So x is either 3 or x is equal to minus 1. So these are two ways that you can use to solve a quadratic equation. And let's remind ourselves again of the form of the equation. So usually a quadratic is ax squared plus bx plus c equals 0, and the formula is x equals minus b plus or minus the square roots of b squared minus 4ac divided by 2a, and this gives you the right answer. So sometimes you cannot factorize this in the way we did before. Sometimes it's not possible. So in that case, you can use the formula here. Also, sometimes you're gonna get complex equations, because the square roots of this, square roots has to be positive in order for the square root to exist. If it's not positive, then the answer is gonna be given by a complex number. For example, if you have the square root of minus b, b has to be greater than 0 for the root to be real. So if the root is a real number, then b has to be actually less than 0, sorry. Yeah, so it has to be less than 0, because here's you have a negative sign, so the negative sign times a negative number is going to give you a positive number. If you have the square root of b, then b has to be greater than 0. And also, the square root of minus b is equal to the square root of minus 1 times the square root of b, which is equal to I times the square root of b. I is equal to the square root of minus 1. And sometimes these solutions are going to show on the quadratic equation.